out and have your note packets out to where we left off to. Check the front. So guys, check the front please. Make sure and mark off what today's day is. Are we starting day 6 today? Is that right? Okay, 7 is review and then 8 is the test. So make sure you're keeping track. That means that we're on schedule to take our test. What day? Thursday? Okay. And Friday we don't have school, is that right? Okay. So make sure, please, you understand on Thursday morning, is this all? Thursday morning when you come in, that's what's going to be happening. We should, by and large, do pretty well. Where did all of those questions, where did the last 2 questions come from? Wow, where did the last 2 questions come from? Yeah, they were the exact same questions from the homework. One of the things I always think is funny is when, and this came up on the last one that we did, someone was like, well, I didn't do well on this. Well, that means that you didn't do the homework. I mean, the questions, I didn't even change the numbers. So hopefully we did very, very well. Let's go in right now. We're about 60 days in. You should know by now what we're going to be doing. We left off on page 31. Read out that first question, please, on 31. We'll have you sign into your calculators in just a second. Yep, you can do that now then. Go in, please, and answer out question A on page 31 right now. You should all be able to sign into your calculators at this point. Read out and do question 31A right now. Yeah, or just get out of the screen and then go back into it. That's you. Emily, what's it going to take to answer out question A? And do what to those? There you go. So this would actually be P of 5 minus P of 0 over 2005 minus 2000. It's the change in Y over the change in X, T years after 2000. That's why it's not plugging in 2000, it's plugging in a 5. When we do this by now, sign into your calculators. We still have 5 or 6 of us that need to go through and do so. Not new. Go in right now, please, and let's evaluate out what the function's value is at 2000 and at 2005. So go into your calculators. Let's do it this way. This way will probably be the most efficient way. Go in right now, please, and plug in the expression that represents the function. So everyone right now, go in and plug in the expression, and then do the bar. No, not with the y equals. Delete that y equals that's in there. Then put a bar after it. What would we do, Alyssa, from here? Which is going to be x or t equals or x equals what? Nope. We got to start off with our Well, we could do it as let's do the 5 first, because that's the one we're going to list out first. And then we need to plug it in as to represent the year 2000, what would our input be? 0, yeah. So we have our two values, and then we need to divide that by 2005 minus 2000. So you can go right into your calculators at this point, set it up doing control division, so go through and hit that. You need the function at 2005, exact value, minus the function at 2000, all over 2005 minus 2000, get typing. Love that we watch. And wait to be safe. So here's the work that you would be expected to show out on your paper right now. And it wanted it rounded to what position? Hundredths. So this is what your papers all should look like. So what would your answers be to this question? Trevor?
It would be 1.16 million per year.
There you go. Now the units were given, so you don't need to necessarily tack that on, but that's what we should be getting. Questions on that? Everyone should get this right 100% of the time. There's not an excuse as to not to get this. Take a look at the B question. It says, based on the model, the solution to the equation gives you the number of years it will take for a country of population, or the population of country A to reach 50 million. Algebraically determine a solution to that equation exactly and to one, and as a decimal to the thousandth place, confirm graphically. So the first thing I'm going to do is solve this equation out. And it says, well, P of t is going to be equal to 50. That means take the P of t equation and set it equal to 50. So that's 40 e to the 0.027 t power is equal to 50. By the way, I'm looking at this right now. Again, for those of us who are, and we're answering this question now because hopefully it's easy, that half of the equation models a function. What type of growth is shown by that function? Chloe? Looking at this function, what type of growth is shown if that's the equation to model country's growth? It's a continuous growth model. What is the rate of growth going to be? Nope. Hands up, please, if you can tell me what the growth on this is going to be. You tell me. We've been looking at the same thing for a long time now. 2.7%. If it was decay, it would be negative 2.7, etc. Now, our task is to go through and solve this equation out algebraically. The first step, when you do that out, that I'd always advise you to do, you're free to do as little as you'd like. I always ask that you circle the base and exponent. That way, solving for it is going to be a heck of a lot easier. So, looking at what we have, Johannes, what would you do to solve for the t now? Divide both sides by 40. So when I do that, we've got e to the 0.027 t is equal to 5 divided by 4, 5/4. What would we do now from here? Noah?
You would find what e to the 0.027 power is.
No, we can avoid that piece of it. He's saying compute and determine and alter the base. That gets us to the same thing. You tell me what we would do to solve this out from here. Seriously, 3 people? Jason?
What I would do is apply, like, I guess what you call the law of exponents, and say the quantity e to the power of 0.027 and quantity to the power of g.
We did that part. That's what he was going through and saying. That's the same thing. We're not moving forward with that one. Yeah, what's this going to look like if we put it in logarithmic form? You could also, who could give me another way of writing this? She gave me the most condensed way possible, so I know she knows what's going on. What's another way of giving this out that's equivalent to what you just wrote out? Jonathan?
Log E.
Yeah, log with a base of e. They mean the same thing. Looking at what's there, though, we're to this point. What do we do now? I'm asked to determine what our t value is. And then do what to it? Now, the question specifically asked for an exact value, which means, and this will tell you, you can go through, most likely on most Regents exams, you would go through and say, all right, this is, we do this, yada, yada, and you go to the decimal right away. This question wants the answer exactly. That means you're going to go through and determine what it is exactly. If you have to round, is that an exact answer? No. So right now you can actually tell me what is your exact answer. Hands up, please, if you can tell me that. What does t equal exactly? No rounding at all. What is t exactly? Go ahead. This would be the exact answer. Was it 0.027? Okay, that's the exact answer. Now the next thing we have to do is to go through and group this. The next thing I have to do is give an approximate answer. So, that's when you go into your calculators and you give out your approximate answer. So, Sarah, what is this approximate answer going to come out to be?
8.265.
Okay, so 8.265. Questions on that? Now, we still have one thing left to go through and do. So, the last thing is, it said on there to show it out algebraically, or sorry, show it graphically too, is that right? How can we get our answer graphically? Well, we've got to do two things. You're going to go right now into the graphing option. So instead of going and getting a whole new document, we can't just get a new problem. So go into hit, go in and please hit, do we hit menu, I think it is? Oh, sorry, I think if we hit doc, sorry, hit doc, go down to, let's see, insert. We can go and insert a problem. And then we're going to add a graph to that. So we're sort of starting fresh. From here now, you're going to graph out the two halves of the equation and figure out where they intersect. So go into your calculator, plug in the first half of it, and then the second half of the equation. So what two things will we be plugging in? The equation has two halves on it, the one you just solved. It has a left half and a right half. You're going to plug each half in as a separate line, and we're going to figure out where they intersect. So the first half would be 50. What's the second half going to be? You got to graph another one. What's the second half going to look like? 40e to that power. Now, this always comes up too. Somebody will screw it up and put in a t instead of an x. Now, get out of that screen. No. Oh, hang on. We'll get to it in a second. Right now, think about what you're looking at. And some of you are going to go, I don't see anything. Who can tell me one reason you're not going to see anything? You should look at this and go, yes, I know. Obviously, you're not going to see anything, nor should you be expecting to see anything. Emma, what do you say? Yeah. How high? What's one of the lines we're graphing? 50. So, and by the way, which quadrant do we need to look at out of all four of those? What's the only quadrant that we're going to be looking at? Michael? First quadrant. So let's go into our calculators and let's do this. First thing that we should be going through and doing is go into your Windows settings. Our x-min should be, let's say, -1, and our x-max. Now, by the way, where did we say the intersection occurred at what value? What did we say it was? At 8? All right, so let's go from like -1 to like, instead of, so we can see 8 kind of clearly, let's make it like 15. And our y-min should be like -1. Our y-max, though, it's going to be at least 50, Let's try to make it, I don't know, 100. We can always change it if we need to. This is why, we say these are sometimes like Zoom stupids, because you've got to be able to think your way through them. The zooming is just blind, completely blind. This is much more indicative of what we want. Go into 8 for geometry. Points. No, go to points. And then find your intersection point. You're going to select this graph and select both of them. So what's that going to be? 8 point, what did we say? 265? Is that what we got? So did we confirm it? Yes or no? That's what you need to now put on your paper. A sketch of this, showing both equations labeled. There's 3 things that need to be there. You need to show me a graph in the first quadrant. Show me this representation of it. And then you need to go through and show me what the point of intersection is. Label it. So 0.865, comma 50. And label those 2, not lines, but those 2 graphs. Yes?
Do the thing where you like throw the more decimal places?
I can't hear what you're saying.
How do you do the thing where you can see more decimal places?
If you want to do it, you can hover over it, but here's a shortcut to it. Go into doc. No, sorry, go into try menu, go down to 9 for settings. Now, that way it changes. If you change it to like float 10, you never have to worry about hovering over. Wasn't it in here where we struggled to like get it to do the claw so you could hover over and hit plus? I thought that was the case. If you change it in here, it will automatically show 10 instead of 2. But there's more than one way to do it. So you can either hover over it, get the hand to look like a claw and start hitting plus, or you can go back and change what the graph and geometry settings are and work from there. Okay? Questions on that? All right, so we answered that question. Now the next one. Based on that model, what year will the population of country A be greater than 50 million for the first time? When does it hit 50 million? Alexa, what year are we in when it hits 50 million? Year 8. So what would your answer be to C? Close. If she wrote 9 on her paper, she's getting 1 out of 2. Actually, might even get the whole thing wrong. I don't know. Be a 2-pointer, but not full. Jonathan?
Years.
What's that?
9 years.
Nope. 2009. See what the question says? In what year? You could say, well, it would be when t is equal to 9, so the year would be 2009. Questions on that? Next one up. For another country, country B, the population M in millions, t years after 2000 can be modeled by that function, where t is greater than 0. Based on the models, what's the first year in which the population of country B will be greater than the population in country A? Now, there's a lot of different ways that you can do this. You can do it as a table going across and literally plug both of them in and figure out from a table when B goes above A. You could do something else. Go through right now and graph these 2 out, these 2. So I guess we could go into what we were just working with and maybe change some stuff around. So go in. We can even work from that same document. You're going to graph out both of these and figure out when they're equal, and then we're trying to find when country B is greater than country A. Now, if I'm doing this out, I want to go to menu. Let's go to Windows settings. let's make our time be out to like year, I don't know, let's try 100 years. So from like -1 out to 100. I always do -1 so I can see the x-axis. And my spacing I'll make by 10 on the x-axis. Change our x-axis there just so it's 10 so it's a little bit easier to see. I think if you delete it, it'll come up as, you can just type in 10. Our y min, let's make it -1. And let's make it go up to 200-ish. Scale be by 10. Now, what do we notice about this? What's that? Yeah, so I guess I'd say this. I think that the question might be incorrect. Because if they intersect in quadrant 2, it was before 2000, and does the model apply before the year 2000? No, so let's do this. Does anybody know what we could get rid of that would make this workable? Let's get rid of that negative. So go in on the second graph, get rid of the negative because that means the second graph will start out at a lower population but increase at a faster rate because the growth on the second one would be 0.42. Now, can we see where that's going to... Okay, now let's find our intersection point. So we'll go back and change it. We changed that equation. Let's find our intersection point between these two graphs. And what year is that going to be at? You got to select the second graph, and then it'll show up for good. All right, now, what year will that second country overtake the first country? In 2009? Well, sorry, let's make sure we're answering the question right. What's the first year? So since the first year would be 2009. Now, and you, if on a read, you go through and sketch the two graphs, show the intersection points, yada, yada. The one thing, though, that you all need to make sure that you all are hyper-vigilant about is understanding the process. What does the 35 in the function represent? We already said before, it's continuous growth model. What's the 35 represent? Trevor? And what does this right here represent, Trevor? What's that coefficient for the t represent? The rate. And that's the whole point. He said it correctly. What is this? What's happening in country B? And it shouldn't make sense because which country starts out with more people, A or B? A. And which country is getting, which direction are the countries moving in? A starts off higher and grows. B starts off lower and decreases. So are they going to intersect? Not unless we make that manipulation, at which point B starts out lower and starts going up and increases faster. Now, here's a great one. Environmentalists will capture an endangered species and transport the species to a controlled environment where the species can produce offspring to regenerate. Again, understand, are these supposed to be interesting? They're like mental Novocaine. They're going to numb you down. So the birds, wonderful. Now, suppose 6 bald eagles are captured and set free. Based on experience, the environmentalist model the population of bald eagles after 2 years to be dead. Holy cow. What a long way of saying a lot and nothing interesting. Now, what is the predicted population of the bald eagle in 20 years? What would we have to do to answer out A? We got 2 people. Fabulous. Look out MIT. Jensen, what do you say? Yeah, so we're going to evaluate out P of 20, and notice you're not even thinking to do this. It's 500 over 1 plus 83.33 e to the negative 0.162 times 20 power. So now you go into your calculator and you evaluate it out. Plug it in. I always do it with the bar trick. Plug in the original expression with the bar. You can do it with the 20, doesn't matter. Hit enter. Now here we go. What's the answer to this question going to be? Okay? You can't have 0.27 of an eagle floating around. Next one up, when will the population be 300 rounded to the nearest year? So, what would we do from here, Allison, in order to get an answer? What would we do now from here, Peter? Who can tell me what we do for this question? One, two of us? Jason?
You would multiply, or you divide, no, sorry, multiply both sides by 1 plus, 8, 3, 1, 3, 3, e to the power of -0.1.
You could. Who's got another? Wait, you're going to get to the same thing. You will get to the same answer. Jonathan? Just cross multiply, get you to the same equation. So this would be 500 is equal to 300 times 1 plus 83.33 e to the negative 0.162 t power. We need to solve for the t. So, Peter, what would we do now from here? Not distribute. Yeah, let's divide both sides by 300. That's going to leave me 5/3 is now equal to 1 plus 83.33 e to the negative 0.162 t. What happens next from here, Tyler?
We would subtract 1 from both sides.
What's 5/3 minus 1 going to leave you with?
So we do 2/3.
So we've got 2/3 is equal to 83.33 e to the negative 1.62 t power. Whew. Haley, what do you do from here? Is your hand getting tired? Do you hate eagles yet? Good. That's the goal, to make you hate an eagle. Who can tell me, please, what we would go through and fill in on the left-hand side? You tell me, what is that going to... Michael, what am I writing out on the left? I didn't say round, so 0.00.
0.008000. 3200.
I'll stop there, but see how it goes. It's not just that. It continues on. What would we do now from here? Hands up, please, if you can tell me what happens at this point. One person. Jack? Okay, so what are you going to write out? Get up. So I'm going to divide both sides now by negative 0.162. Those are now gone, and it would be t approximates 2. So go into your calculators. Now, here's one thing we need to make sure of. Nope, whomever this is, go back, delete what you have there. You need to select this up here. Use the exact. Stop, don't ever round. Plug the whole thing in, divided by, what was it, 0.62, or is it negative something? Okay. And what do you get? 29.804. What does it want our answer formatted to? When will the population round the answer to the nearest year? So, what year would you give out as your answer? Hands up, please, when you can tell me. What?
30 years.
Nope. Be careful. Oh, it doesn't give an initial year. I'm sorry. I'm sorry. Maybe we take 30 years later or something to that effect. Okay? Questions on that? All right, next one up. And this, by the way, is an actual thing. Like, we actually have it even happening now. Raise your hand if you have if you had or have a birch tree on your property. If anyone had it, you have one. Do you know why? What's so special about birch trees? Anybody know what's so wonderful about them now? Yes.
I mean, when I was something done on peel the bark on
You can peel the bark on it. They're all. Is yours white? Yeah. The problem is, no one knows what the problem is with them. Not them themselves. But there's a thing called a birch borer, which is, if I remember right, and I could be wrong, I think that they got imported into America and into New York State somehow. Literally was some lumber that contained this bug in it. And if I remember correctly, they came from some Asian country, but I'm not 100% sure. And they're these little bugs that go in, and like some sort of beetle, and they literally get into a birch tree, and and they lay their eggs. And then the eggs, in order for them to hatch, like the larvae, you know how like they need something to eat, like when it's like a little, whatever, gross beetle thing? It starts off and they need something to eat, so they lay inside of the birch tree, and it eats the inside part of the tree. And if you got one of them, is it really an issue? Probably not. But what's the problem with bugs? They multiply quickly. So what ends up happening is they get inside, and they only do it to birch trees. So they get inside of birch trees and start eating the inside. And so the tree on the outside looks normal. And then when you, the tree though is really weak and they start falling over, and literally when they fall over, you'll discover a giant tree, gigantic, will have a trunk, like as big as this table, and this much of it will be completely hollow. Like there's nothing on the inside at all. And so the tree falls over, and the problem with like introducing a new species, do they talk about invasive species in like a life science class or something like that? The problem with that is the birch borer has no predators. So they literally, every year, it would get worse and worse. And some people who are not so bright, for some reason, like these people are obsessed with like transporting logs for some reason. So they like bring their own like firewood from their house to the Adirondacks or vice versa. And so like New York State used to have millions of birch trees. And now we're at least down to maybe 1/10 of what we had before. And they all fall over. And I know personally because in 2010, 2008 maybe, I bought a house and it had this beautiful white birch tree. Literally, it's a ranch, so it's shaped like a rectangle. And it was literally like right next to one of the bedrooms. And it was gigantic, huge. And I just remember I was literally mowing the lawn with a push mower. And I was mowing, and all of a sudden, and I had my headphones on, and I turned around, and I felt something scrape the back of my leg. And it was literally a tree branch that would be probably from at least here to the end of the room, fell just completely down and missed me by maybe a second. And it literally would have fallen on me, and probably some of you are a little bit lamenting that that happened, because if I had been a second slower, it would have fallen on me and I probably wouldn't be here today. And when it fell, I had no idea what the hell a birch borer was, and I went over and looked at it, and the branch, which again, for a tree to grow sideways, the branch was growing. The big stalk was still there. Forever, whatever this branch coming out of it would be called, but it was big. It was, in order for it to support the weight from here to here, it's got to be pretty thick. And it literally looked like a straw. Like the inside of it was hollow. I could see out the other end of it. And like literally you could punch it and it would cave in. And you'd think that that would take a long time to get out. I dragged by myself the branch from that was this big. I grabbed an end of it and I was able literally to drag it. Now it took some work, but I was able to drag it. It was probably maybe 300 pounds. That's it. For a tree branch that long, that's at least 1/10 of what it should weigh. Because the whole inside of it was hollow. And then the scary part was there's still a gigantic thing right next to the house coming over. The guy, when he came from Birchcrest, literally put a rope on it and goes, all right, watch this. And he pulled on the rope, and the tree fell right over into the yard. And it crashed and like shattered like a vase would. But it was a gigantic, colossal thing. So these things happen all the time. And actually, did any of you near, I think that they're in Canandaigua Lake. Has anybody been at or near Canandaigua Lake? Do they have those mussels or something in there, or like algae? Do they talk about invasive species with Canandaigua Lake? Zebra mussels, that's it, because you can't go out because they cut your feet. Have you been cut by them?
Not as bad anymore, but yeah, I know.
Your feet get cut, especially if you're not expecting them. And the problem with invasive species is there's nothing there to get rid of them. This actually happened, and that's why when people get exotic pets, it's just mind-numbingly stupid. First of all, somebody brought these snails into America somehow, and they're like, first of all, who the hell is it? Who's going, oh, Mom, can I get a snail? Second of all, what kind of moron goes, oh, here's a snail that's never been in America before. Let's throw it out in the yard and see what happens. But that's actually what happened. The grandmother was mad at the child for getting these and wanted to punish them for like not doing their chores or something. So they literally put this giant snail out into like their garden, and it's like a Tyrannosaurus Rex of snails. They get huge and they just destroy everything, and they're actually so big that nothing can eat them. So they literally had to go around, and like the Department of Environmental Conservation was like taking them and like taking them. Even if you go down in Florida, if you have relatives down there, or maybe they've talked about it in class, I don't know if it's boa constrictors or pythons. Maybe it's like a Burmese python. I don't even get why people would want pets. Not to judge, but this is personal judgment. Why someone would want a snake for a pet is beyond me. Like they're not cuddly, they don't do anything. You're just sitting there staring at something that would probably be rather outside. You're both looking at each other like with this mutual look of disappointment all the time. The snake wants to be outside and away from you, and you're looking going, God, I'm so boring, I'm looking at a snake. They take the snakes down in Florida, and these people go, oh, the snake is like too big. So what do? They dump it in the Everglades, or like in the woods. So the Everglades now is littered with snakes that are cute. We're talking, they eat deer. That's no kidding. They actually eat deer. Like that's how big they are. And there's nothing that goes through and eats them. So down in Florida every year they have like this hunt-a-thon, which another thing you want to do is, of course, they tell people, go take your guns out to the Everglades and shoot these snakes. We'll give you $1,000 for each one you bring back. So you have a bunch of people with guns trying to pull out, or whatever they have, maybe machetes, trying to pull snakes out of the water. What could go wrong? So every year, like 1 or 2 Floridians, like they might get like 8 or 9 snakes out, and then you lose like 1 or 2 people. But the snakes that they pull out are colossal, just huge, huge. And that's what happened with these snails. The person went through, a boy smuggled in 3 for some reason. His grandmother, here's an idea, get a dog or a cat. There's thousands of them at a shelter, and they don't eat any. Cats eat mice. We don't want more mice. Grandmother let them out into the garden. 7 years later, there's 18,000. Now, they're actually gone because the DEC went in and literally, one by one, picked up 8,000 slugs. Assuming that the population grows exponentially, write an expression for the population for the number of t years since the release. Now, round your coefficients to nearest thousand. When we're doing this, you can get 2 data points from this. Who can tell me what the 2 data points you can get? Because in order to get an exponential regression, you need 2 data points. What are those 2 data points going to be? We got 1, 2, 3 people, 4, 5. What would the 2 data points that we're working with be? Emily, what do you think? So we've got 0, 3, and what's the other one? So you could say kind of this was an environmental disaster. Let's go in now. You're going to give me an exponential regression to model this. So go into your calculators. Let's go back in. We're going to start a new spreadsheet. Just take an exponential regression. Let's do time in years or years, whatever you want to call it. And see, we can call it snakes. Go through and compute that out, round it out. Let's see what that's going to come out to be. What is this called? What is it called? Land snail. There we go. Oh, this is so gross. Okay, so obviously, would I harshly judge someone who thinks this is a pet? Yes, that's revolting. Okay, here's an idea. Instead of getting this for a pet, you know what you could go through and get? Oh, okay. So you don't want this. We all make choices. Let's choose wisely. And if someone says to you, hey, I've got a snake at my house, you might want to say, awesome, why don't you change my number out of your phone? Let's go through and figure out what this is going to come out to be. What would you give out, Alyssa, as your answer? That's right. When you get it.
3 times 3.465
Nope. You got to round to the thousandth, so 3 spots. Is that rounded correctly? Yes or no? Okay. If not, yes or no? What's after the 5? A 2? All right. How long does it take for the population to double? Now, how long does it take for this population to double? Trevor, what would you have to do to answer that?
You plug in, wait, so it would be 6, but it's a lot.
There you go. He said it perfectly because it took you a minute. What were you going to go back to find?
I was going to put like 2 and 3x.
Yeah, but that doesn't make sense. He instead was smart enough to go back and say, well, wait a minute, what was my initial amount and what was the initial amount? 3. So he doubled it and gave it 6. So this is going to be equal to 3 times 3.465 raised to the x power. Chloe, what would you do to solve this out? Divide both sides by 3, and that leaves me with 2 is equal to 3.465 to the x. What are we going to do from here? You tell me what finishes this off. You're going to use a log. I'm going to say this. Your homework for tonight is to finish up these questions. We'll say this. Get done. Yeah, finish up the questions that are there. They should go quicker without me yammering on. The reason that I tell you that is when you come in, your assessment next time is going to be based on those questions. All right? Have a great rest of your day, love.
Sorry, I thought it was
Scott?
Yep.